Hello, everyone, and welcome to AWS Heroes in Conversation. Today, we are going to discuss about awesome Dyna53, and we have Alvaro Hernandez with us. So, Alvaro, welcome to the channel.
Thank you. Thank you very much for having me.
Absolutely. And just so that everybody knows, Alvaro is a data hero, and he's based out of Spain. So, Alvaro, why don't you go ahead and introduce yourself to our viewers?
Sure, of course. So first of all, as you already said, I'm an Amazon data hero since 2019 and recently now renovated now in 2023. But other than that, I am a passionate open source person. I like to work on R&D, especially on the databases area. So I'm constantly trying to research and innovate into new products, new solutions in this space. More specifically, I'm actually focused on open source database technology, which you all know very well, Postgres or PostgreSQL. Actually, I founded a company, a startup called Ongres, which means on Postgres. So it's very obvious what we do, right? Everything Postgres we do, nothing else than Postgres. And so part of my work is to create these new solutions, this R&D into technology. We have built, for example, an open source software also called Stackres. Stackres is the stack of components you need to run production quality Postgres. And this works on and runs on top of Kubernetes. So it's a platform for running Postgres on Kubernetes. This is kind of the work that I do. But in reality, I'm just really an open source lover. I've contributed to many projects, helped bootstrap, in Spain, for example, the Vienna Association, then the Postgres user group, created a nonprofit foundation also rooted in Spain, but with international goals to promote Postgres. We organize a conference, International Postgres Conference. And in general, I obviously love the cloud and I'm around to help anyone to share my passion about the cloud database technology in general. That's what probably could define me.
A little bit about you. Perfect. No, this is great. So, yeah, guys, we've been trying to get this session recorded for a while, of course, with Alvaro being in Spain. I'm technically in US, but right now I'm in India. So let's see how far we go around this time. This is the third time we've been trying to record this session. So hopefully you guys enjoy the session. Alvaro, over to you. Why don't we continue further ahead and deep dive into Dyna53?
Thank you very much. All right, so I already introduced myself. Just if you want to get some more pointers about myself, you can go to my personal website, ht.es, or email me or Twitter me, and I'll be around. So let's jump into this idea of Dyna53, right? This is a very new, surprising technology that I announced a little bit before reInvent last year, the Amazon conference, the annual Amazon conference happening in Las Vegas, right? And so what it is, well, if you're aware, if you know DynamoDB, you already know what Dyna53 is because it's the same thing. It's DynamoDB, or at least let's say DynamoDB API compatible software. So whatever you use on any tool, you may use DynamoDB, you can use Dyna53. But okay, there's a few small differences. It's still a global database, right? For example, so you can access from anywhere around the globe, and you will get DynamoDB, this DynamoDB API, right? The small difference is that Dyna53 stores data, not how DynamoDB stores data on sharded partitioned databases. Currently, it uses a derived version of MySQL under the hood. Well, Dyna53 stores data on Route 53. I mean, in the DNS. And yes, it stores data on a DNS. And so this is a bit strange, probably, you may say. Why you do this? And how is it possible to store data on a DNS server? Well, the idea is not new, and I'll talk about how I came up with this idea, but it is possible. So this is essentially taking a DNS system, in this particular case, Route 53, Amazon's Route 53 system, and exposing it with a DynamoDB API compatible interface. So this is good. This is interesting because first of all, it uses Route 3, and Route 53 is, as a very well-known person in the Amazon community says, Corey Quinn says, that Route 53 is the Amazon service with the highest SLA in the world. It is the only one that has 100% warranty SLA from Amazon, right? But at the same time, you can still use DynamoDB API to interact with the database. But because it's DNS, you can even use DNS. And we'll show this, how it works, right?
Yep.
So how do you really store data? You take a public zone, or you can even use a Route 53 private zone and store your data. That's all that you need for storing the data. So I say that this is Corey Queen's dream came true, and I'll share with you why this is the case. But
so you came up with this whole idea by yourself, Alvaro?
Yeah. So that's part of the story. Let me jump on top of the story because it's partially true and partially not. So I was heavily inspired by Corey Queen. He wrote a blog post. You can read it on the web on his newsletter called Last Week in AWS, called Route 53, Amazon's premier database. And through this blog post, he kind of posed this as a joke, like, Route 53 should be the premier database because of this SLA, because of the low cost, and because you can really store data on Route 53 or any DNS in particular, right? So he threw this idea to the wild at some point. And it's just not the idea, is that he told the story of how he came to this conclusion. And this story is that a decade or whatever, how long time ago, really at a company, he really stored data on a DNS. And when I read this blog post, this totally resonated with me. I actually did the same. A couple of decades ago, I was working in a company, and we decided that to keep track of all our servers, we had to store a database of information about the servers, from the IP addresses, obviously internal domain names, but also the IP and MAC addresses, the services they're exposing to the other parts of the network, even the serial codes for warranty validation purposes, and other information, kind of, we would call it today tags of information about all the servers. And we decided to store this on an internal DNS because it was great, easily accessible. There's not sensitive information. You can query by different record types. There's service record types for this specifically. So when I read the story from Corey Queen, it really resonated with me. And I said, oh, I've seen this before. I felt this pain, or actually tried to implement the solution. So this is so fun. And since then, I had in my mind, I have to do this, I have to do this, I have to do this. But then I came up with the conclusion that Route 53 can be a database. And actually, a few people did this. There's a few open source projects that took an interface and created a database on top of Route 53. But for me, it had to have a real database interface, an API that people will recognize, oh yes, this is the database. Not a new API, because then nobody will use it. It's not that this Dyna53, I expect anyone to use it in reality. It's more of a joke than a serious thing that you will use for production. No, please don't use for production, right? But it had to have a real database interface. And I thought DynamoDB, which is in reality, is a REST API. It's something easy to clone, to mimic. Of course, it's only a subset of it, and to expose a real database interface. You can use DynamoDB GUI tools to interact, and data is in Route 53, right? So it really works as a database.
Well, this is good. I mean, I think maybe we should share the URL to this particular article if you have.
Sorry, which one?
Do you have a link to this article that was written by Corey Quinn?
Oh, yeah. I mean, it's quite.
Maybe I'll share it with me later. I'll put it in the description of the video.
Absolutely. Okay, so this is the idea, right, behind it.
Okay.
Now let's look at how it works. And let's look before that about the reactions, because it was quite funny when I announced this on Twitter, right? So some people said, why would you do this? And my answer was, because I can, right? It was just for fun. This is part of my daily life. I don't get to code a lot on my daily basis. I'm still a CEO. So, but it's my hobby. I love it. So whenever I have some free time, I try to get some time coding. And I thought I can do this. So why not? So when people ask me, why do you do this? I have to say, because I can, right? Because it was fun. It was fun. The product, the software is fully open source. You can go on GitHub, you get the address there, and just fork it, star it, please, if you like it. If you think I'm crazy enough, just give it a star. I mean, it's not going to take me anywhere. I'm not going to go VC with this. It's just a fun joke, right? But I'll be happy to see that people like the idea. But it actually turned out to be quite interesting that by exploring the limits of Route 53 in this case, right? How to store random data on Route 53 is non-trivial, and it was an exercise. At times, it was hard. There is a lot of limitations on Route 53. Limitations if you want to store random data, not as a DNS system, that I have to overcome. And like, for example, if you want to store a very long string, like a JSON document, right, with 2,000 characters, for example. Well, you need this. If you store this on a text field, which is the only option for something that long, you need to strip it into chunks of 255 characters, and then put a separator in between, and then escape some characters. But then, if you're also using some characters outside of the ASCII 7-bit control plane, then you need to escape them. But then the escape string is longer than 255, and then you need to cut them in different ways. So it becomes quite cumbersome. And there's no double escaping. There's a lot of limitations, again, if you're doing weird things, not for normal use cases. So I had to overcome all these limitations, but at the end of the day, it was quite fun. So
that's good.
Source code is there. Go, feel free to explore it and submit pull requests if you want. It was fun.
And I think we have a challenge also for our viewers, right? I mean, towards the end of the session, we will announce a challenge, and whoever wins the challenge, it's an open challenge to anybody who's watching this particular video. Whoever wins it or is able to identify the issue, I believe will win about $50 or so, right?
Yes, there is a challenge, and we
Okay.
have a prize. Yes.
You have a price as well. Awesome. So this is good. So guys, be attentive, and let's continue further ahead and figure out how this thing works.
All right. So let me talk a little bit about the architecture, right?
Sure.
Yeah, the architecture in reality is quite simple. There's nothing super special here. First of all, you can see on the left of the screen, you're going to use the DynamoDB client. It could be the AWS command line, could be any GUI tool. I've checked with Dynabase; it works very well. Like essentially anything you want to use that is Dynamo, your app that you built with DynamoDB, and then it should just work. Well, not the full API is implemented, obviously, actually a small subset. But the usual very simple operation script, table, put item, scan, get item, they just work, right? Also with not all the options that they support. So it's a subset, but it's just the idea, right? Then it can actually be deployed in two ways. It can be deployed as a Lambda, and this is the ideal from a serverless perspective, right? DynamoDB is a serverless database. Route 53 is, well, I don't know if it's fair to call it serverless, but technically serverless from the perspective of the user. We don't manage any servers, we pay by consumption, right? And so you can deploy as a Lambda, and then you get the benefits of Lambda, also serverless, scaling, etc. But because this is software, you can run on your laptop, and later I'll do a demo. I'm just going to run it on my laptop because you can also do that. Then you can deploy on your own environment, on your laptop, or an EC2 instance. It's really up to you, right? So deployment model is quite flexible. This Lambda or this deployed software is a software. It's actually programmed in Java, and is the one that exposes to the world the DynamoDB API, and then converts internally these into Route 53 calls. It uses the Amazon SDK, the Java SDK for Route 53. And then it calls Route 53, which is here in the right side of the screen, right? And calls Route 53. And then stores the data or reads the data from Route 53. So if we look at this is actually on the bottom of the screen, you can see a screenshot from the DynamoDB console. And this is how records look like. So if you're wondering, okay, you're using Route 53, you're using a DNS, how do you store data on the DNS? Well, it's kind of interesting. For example, the table definition here, the first record is stored on a service record type, DNS service record type, because it's a service. Could be a text field, but I thought it was cute to split data into text fields and tables into service records. And here, actually, you can see there's a JSON document. It's actually not JSON. It's very interesting. I had to create a small derivative of the JSON standard where quoting is with single quotes instead of double quotes. And the reason is otherwise everything will be escaped. All these double quotes will be escaped and they look terrible. It's not easy to look into them. So I prefer to create this kind of single quoted JSON, which is not a standard, unfortunately. I was trying to see if there's a standard for this. There is no. And actually, the libraries that usually deal with JSON had some struggle with this. They're not used to. But it looks cuter on the screen, right? So here's a table definition, for example, and the two records that you see up below them are text records are the real data. So this is a table called single table with two records. And again, the records are stored as JSON-like records, this single quoted JSON. And the primary key of the table is hashed. And it's also hashed, again, limitations of Dynamo, Route 53, sorry, in this case, they're hashed with SHA-224 because it's the longest hash that converted to base 64 fits on the maximum length of a record in Route 53. So the primary key is hashed into this BF8, FF8, or DDBB, blah, 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 record names on the, you can see on the left, which is how we can find these records by primary key. So this is the mechanism for primary key lookup mechanism in Dyna53, right? So it's, again, conceptually, it's a simple stuff. DynamoDB API, Lambda or hosted solution with the custom source, and then Route 53. To run this, you just need to set up a Route 53 zone, hosted zone. You can even technically multiplex, so nobody prevents you from using multiple lambdas or multiple hosted the software pointing to the same host zone. And so, you know, you can make it multi-tenant. But there's also limitations in the number of records you can have on Route 53, so you can have at least 1,000 records.
Plus, Route 53 could be an expensive service also, like if you're doing at home. So people need to be careful of that.
Yes. Yes.
No, yeah, it's a very simple setup, so that's for sure.
Exactly. Again, this is just for test. I mean, I've built these 10,000 records, and actually, what is difficult is to delete them afterwards, because you cannot delete them as a whole. There is also a limit. The delete order contains the whole record cannot be longer than 32,000 bytes. So deleting is complicated. You cannot just say delete everything. It just doesn't work, right? So. Yeah, but again, this is just for fun. This is for testing. This is for the technically curious person, right? But this is the architecture in a sense. Also, I run some benchmarks. And why would you run some benchmarks for this thing, right?
Maybe because you could.
Exactly. You got it. Exactly. That's the only reason, right? Because I could do this.
You could do it.
And the best thing, or the most important thing here, is that I did them so you don't have to.
Correct, like, exactly. And that's why I said people will buy it any which ways, and you are providing them benchmarks. So
yes. Yeah. I hope this will be testament enough for people not to benchmark this. Not because the numbers are wrong. I mean, really, feel free to reproduce them.
And also prove that it does something. Right?
Yes, exactly.
When you put benchmarks in front of people and people start believing in things.
Yes. I hope this brings confidence. But really, don't benchmark this. No, the main reason not to benchmark this is, first of all, you're going to get throttled. This is very obviously a pattern of usage of Route 53 that nobody ever thought before, I believe, right? So Amazon is going to see a very weird workload running, and well, Amazon has designed very well their APIs. All their APIs have limits, right? And you're going to hit those limits very soon. I hit those limits very soon. Most of the benchmark had to be repeated after a calm down period of hours. So actually it took a long time to run these benchmarks. And the only reason is that you get throttled very, very easily, right? And that's good. That's good. Amazon is protecting themselves, right? So it's a big effort to run these benchmarks. The cool thing is that it runs YCSB, right? This very famous benchmark for NoSQL workloads. It's capable of running it. And it run, as I said, require no changes. So you can run YCSB. YCSB has a specific module for DynamoDB and works perfectly against Route 53. Sorry, Dynamo 53, Dyna 53. So again, I run this so you don't have to. It's also interesting that in case someone would say, oh, this is a terrible workload you're throwing at us, where you're doing this, etc. The source code contains a small identifier which is sent along every request as part of the header. When I'm using the client, the Route 53 SDK client, so that Amazon can really identify Dyna 53 if they needed to. So it's adding a special header saying, hey, I'm Dyna 53, right? Just in case you want to throttle me even more than you're doing as usual, or you want to throw me to the bottom of the quality service, right? QoS, that's fine, right? Like, here's my header, so you know that. So I'm trying to play well. Anyway, about the numbers. So first of all, I ran, here, the most interesting for me is the insert test, because querying is going to be even more throttled in terms of records. But at least, okay, let's look at insert at writes, which is the most important, because this is a globally distributed database, right? You can run, there's no region, it's regional, right? You can write from anywhere. So how fast these writes are. And the interesting thing, which is expected on a essentially serverless architecture, is that it scales very well with concurrency. So obviously there's latency, and if we look at one thread, for example, here, right, the number of inserts per second you get is 4, which is like super slow, right? There's a latency of quarter to a second. But it's a global database, right? And it's doing weird things on the DNS, but then it's get propagated. So all these magical things that happen behind the scenes obviously means that you can do at most 4 inserts per second. But if you scale the number of threads, and I tried, all the powers of 2, and I saw the latency degrading significantly above 128, but that's already a pretty good number. If you go on 128 threads, you can do around more than 100 operations per second. This may still look like a small number, and definitely a small number if you compare to any relational or NoSQL database that can easily do dozens of thousands of transactions per second, hundreds of transactions per second, right?
But your latency is also pretty high over there.
Exactly. Yeah. So the latency latency starts going up, right, at some point, because there's contention, there's the when calling Route 53, but I mean, it's still in the order of acceptable. You went from quarter of a second to 1 second.
Yeah.
But anyway, if you think about the number 125 operations per second, it's not a small number. If you count, like, for example, if you look at DynamoDB, the pricing model in terms of millions of operations per month. 125 operations per second will, I'm not doing the math, but will take you to many, many million operations per month. So it's definitely not a small number. If you think on DynamoDB terms of millions of operations per month, this is doing many million operations. So it's not that low, but you'll get throttled. So in reality, those are
relatively, if you go to see 128 threads, 125 operations per second, I'm going to say 1 second of latency. That's not bad, right? Because you're 128 threads.
Exactly.
So, yeah.
Exactly.
Yeah.
But anyway, again, I don't expect anyone to run this in production anyway. And as you said, I did this benchmark because I could, and because I don't want anyone else to do it, right? That's it. So that's it. But it works. It works.
You know that whenever you say that you don't want anyone to benchmark it, that's when people the first thing that they do is go and benchmark it, right?
Yeah. Okay. Then at least do what I did, which is open a separate account to benchmark this. Just in case I don't want your production workloads to be stopped because Amazon thought you're doing some kind of attack, right? So just please do as I. If you want to reference the benchmarks, I'm happy to do that, but open a separate account, right?
Okay. That's fine.
All right. So who wants to see a demo?
Oh, we want to see a demo. Absolutely. Let's do that.
Yeah, let's do that. All right. So I have, in this case, the software running on my laptop, right?
Okay.
Just for easy deployment. And let's use just the Amazon command line, right? So let me, sorry, I'm just using this because it's more comfortable. Can you see the screen well?
I can see the screen clearly, yes.
All right. So I'm using here standard Amazon command line tool, the CLI, and I'm saying AWS DynamoDB, because again, this is really DynamoDB API compatible. Because I'm running on my laptop right now, I just need to pass this extra parameter endpoint URL. This is also standard Amazon CLI. Just point to the endpoint. This could be my laptop. This could be an EC2 instance where I deploy this, or this could be the URL of Lambda if you deploy as Lambda, right? And from here on, anything else is Amazon DynamoDB standard. Create table command, and then create
table. Okay.
Yeah, requires the attribute definitions. In this case, for example, I'm when I create a table with an attribute called HK, which is going to be
HK, yes.
Right? It's going to be a string, and then as I see here, this HK is going to be the hash key. It supports composite keys also, so you can act however you want. Well, pay per request. We're not going to be charged for this anyway. And user table. So I just run this command, and here we have table has been created. Now you may wonder, well, where is it created? So we can try something. For example, let me go to the console here. Sorry about that. It's going to be, okay, let's just reopen it. So let's go to the Route 53 console to see where data is stored. And yeah, I had this open, sorry about that, but it's probably lost on some tab over there. Anyway, let's make the font size bigger. So here you see I created this user table but let me do something interesting here, which is let me show how can I query the table. Of course, I can query with DynamoDB API, we can do that, but this DNS, let me use the DNS tool. So if I do something like this, and then I'm going to query the DNS record for this hosted zone, right? And then, for example, I say, tell me about the user table.dyna53.io, which is the domain name for this zone, the SRV record. Then I should get the table definition. And here it is, the table definition, right?
Oh, okay.
The type is a string, the name is HK, and this is the hash key, and there is no range key on this table definition. So we can see that this is stored on the DNS. Obviously, I can also go on
DynamoDB and do describe table.
Yeah, so I do a describe table, I get the same results. So you can see here that this is being read from the DNS, and I can check also from the DNS side, right? So this is
DynamoDB is basically storing some kind of a reference to the DNS entry.
It is DynamoDB, the client API doesn't know anything.
Okay.
But because we are going through this endpoint, on localhost 8080, I'm running the Dyna53 software. And this Dyna53 software, you need to pass an argument, which is the hosted zone. And then it does the queries and all the magic to get the data. Okay. So let's put some data, right? Let's write.
Yes.
So actually, let me just also look at put item. And for example, let me look for a good command, so something like this. So
put item, yeah, and then add a record, yes.
So the table is called user table. And actually, we don't need the region. We can do that because it's regionless, but let's make it simpler. And we just need to provide the H key, which is the primary key as we define it. And then we can add any additional data here that we want. We can say that this is heroes in conversation, whatever we want, right? And this builds the data. Now, let's query the data first to see that it indeed exists. We can do this in two ways. For example, we can do a get item. I need to pass a primary key to identify this item. This parameter is going to be called key. And then I say get item. And this should return the whole item that we stored before. Oh, and I did something wrong.
One of the parameters is not, I think, we forgot a comma.
It should be like this. And here we have, we're getting the data back. Let's actually look at how this looks like from the console. If I refresh the console here,
you should be able to see those records.
Right? Record here, right? And if I show this record, here
you can see that over there, right? The value. Okay.
Value, right? So it's.
But this one is stored as a text.
It is stored as text. So it's a text record. This is a very good question. This is text record. So all data are stored as a text record. And the table definition is stored as a
service record.
Service record, yes. And for the service record, the record name is obviously
user table.
Name, then concatenated with the zone domain name, right? And for the data, there's a prefix, which is this one, which is the SHA-224 of the primary key value.
Okay, so that is encrypted, right? So that's fine.
It's
and then encrypted. Again, you have the same user table, the table name Dyna53.io.
Yes, exactly. You can see it. See it here. So let's actually add another data item, just because again we can. Let's call this, I don't know, item 2. Let's make this numeric. Let's store some number. Obviously, we need to change the primary key. Let's say primary 2, whatever item. This should also work. And it also supports some other operations, like, for example, the operation scan, which should query for all items existing on
the table.
And here, indeed, yes, we see that there's 2 items here, which correspond to the 2 data points that we have just stored. And obviously, if we go back to the console and we refresh this, we will see that there's now 2 text records here, which obviously correspond to these 2 data points. If I select the latest one, I will see that, yes, this is the data we're storing.
Good. This is a second record. That's perfect.
Yeah. So this is essentially what I wanted to solve. I mean, it just works, right? We can put item, we can get item, we can scan, we can create table, describe table. There's a couple of other minor commands, describe table, TTL, something like this. I don't remember even right now, that are small commands that actually I implemented to get Dynabase to work, because they were running this command, and because it was erroring out, it was like, oh, I'm breaking. But pretty much nothing else is implemented, because again, the purpose here is not to implement the whole Dynamo DB API.
The functionality.
Most upset to make this work and make YCSB, the benchmark tool, run, so I can run the benchmark, so you don't have to.
No, I think this is good. I mean, it could be fun if somebody wants to play with it.
Yeah,
it can be fun to just play with it. And plus, as we said in the beginning of the session, that this is an open source. I believe you have posted it on GitHub, so I'll be sharing the GitHub URL in the description. And I think now it's time for us to get to the challenge, right? So I believe there is an Easter egg or some kind of a bug, in very simple words, that's present in this code. So anybody who is able to download the source code, run through it, and figure out what that particular issue is, will be receiving a $50 AWS credit gift card, sorry.
Yes,
so,
exactly. Yeah. So I built an Easter egg into the software.
Okay.
It's not exactly something that doesn't work. It's something that works, but there is a hidden reference to another technology within the source code.
Within the source code, okay.
Yeah, well, you can also see just by using it. Actually, if you play the video of this session, I've seen it. I mean, I've seen it several times already. I've shown it already. So it's been on the screen already, this Easter egg. Cannot be easier. And if you dive a little bit into my background, you could probably imagine which technology is the related technology. So there is a reference to a technology that is very present on my background somewhere. You can see this, you can spot this in the source code, you can spot this in the demo that I just did, even before also some other places. It's not that hard. And I'll get a $50 Amazon credit to the first one that spots this. So how to do this? Go to the repo and open an issue and tell me what the Easter egg is.
So just to kind of summarize this, go to the GitHub repo, look at the source code, figure out where is that reference to another unrelated technology, right? Or maybe at least figure out what the technology is, where that reference is. And as you mentioned over here on the screen, it's visible both in the web pages as well as in the source code, and then get back to you. So I think your Twitter handle is right there at the bottom. And I think the cover slide already has your LinkedIn. Otherwise, they can just Google your name, and I think that should be pretty straightforward.
Yes. Or just go to my personal page, which is very easy, aht.es, and that's got all the references.
Okay, awesome. So this is good. Hopefully, I don't know, whoever wants to win $50 worth of AWS credits, I think that would be perfect. Awesome. Yeah. No, this is fun. So thank you so much for coming, Alvaro. And I think this was a very good session. I think we had fun. So I will have this posted out, and then hopefully, there is someone who can, figure it out and win $50.
That'll be fun. I'll be very happy to see that happening.
Absolutely. Perfect. Thank you so much for coming, right? And sharing your knowledge with us.
Thank you for inviting me and giving me this opportunity to tell more about this kind of, I wouldn't say stupid idea, but at least fun idea, right? But
sometimes you got to have fun, right? That's the key.
Yeah, a lot of fun. And from a technology perspective, I think it's quite interesting.
No, absolutely. Okay, Alvaro, have a nice day. Take care. Bye-bye.
Thank you very much.